In the early hours of August 15th, 1977, a radio telescope quietly listening to the universe picked up something it was never supposed to hear. It didn't come from a planet, it didn't come from a star, and it didn't behave like any natural signal we had ever recorded before. It lasted exactly 72 seconds. Long enough to be noticed, short enough to be ignored. At least that's what happened at first. The signal was logged, archived, and nearly forgotten. But the universe doesn't whisper without a reason. Years later, a retired astronomer reviewing old data noticed something unsettling. The signal wasn't noise. Noise is chaotic. This wasn't. It had structure, repetition, intent. It rose and fell in a way that suggested control, almost like someone had pressed a button, waited, and then let go. At the time, the technology to analyze it properly didn't exist, so the question stayed unanswered. Not because it was solved, but because it was postponed. Fast forward decades. Artificial intelligence enters astronomy. Old signals are fed into new systems. Patterns once invisible become obvious. And when this particular signal was re-examined, something changed. The AI flagged it instantly, not as communication, not as a greeting, but as a sequence, a deliberate mathematical progression, a countdown. Here's where things get uncomfortable. The countdown did not end in 1977. It didn't end in the 80s, or the 90s, or even the early 2000s. According to the analysis, the countdown was never tied to human time at all. It was based on universal constants, the kind that don't care about calendars. And when scientists adjusted the model to modern measurements, the final phase aligned with a date dangerously close to our present day. But the real shock wasn't the timing, it was the destination. The final value in the sequence wasn't zero, it was a location, a coordinate in space, a precise point mapped using cosmic background radiation as reference. And when translated into our modern star charts, that point wasn't far away. It was inside our galactic neighborhood, uncomfortably close, close enough to be intentional. Publicly, astronomers dismissed it. Privately, meetings were held, data was restricted. Independent researchers noticed funding shifts. Certain sky regions were quietly prioritized for observation, not to search for signals coming from them, but to monitor something that might be approaching them. Here's something you were never told. The signal did not originate from a planet. Planets move. Their signals drift. This one didn't. It came from a fixed point in deep space, a region with no visible stars, no nebula, no known structures, just darkness. The kind of darkness we usually ignore because there's nothing there. Except this time, something was there, something invisible. And then there's the strangest detail of all. When the signal was slowed down and converted into audible frequencies, researchers noticed something eerie. A rhythm. Not a melody, not speech, but a pulse. A steady interval that matched no known natural phenomenon. Except one. The mathematical pattern was identical to the way autonomous systems test environments. Send signal, wait for response, measure change, adjust. Which leads to a terrifying possibility. What if the signal wasn't sent to us at all? What if it was sent through us? Like sonar. Not to communicate, but to check if something was occupying this region of space. Something intelligent, something noisy. Humanity for the last century has been screaming into the void. Radio waves, radar, satellites, nuclear signatures. We have lit ourselves up like a flare in a dark ocean. And this signal may have been the universe's way of asking a simple question. Is anyone there? And more importantly, are they still there? Some scientists believe the countdown doesn't mark arrival, it marks alignment. A moment when something already here becomes visible, or reachable, or active. Others believe it's a synchronization event, a trigger, not for travel, but for observation, as if something has been watching us grow, waiting for a specific stage, a technological threshold, a moment when we become interesting enough to study up close. Think about this. The signal wasn't continuous. It didn't repeat every year. It happened once. Like a bookmark placed in time, as if whoever sent it didn't need to ask again. They already knew they'd come back to check. So the question isn't whether aliens exist. That's the wrong question. The real question is this: what do you do when you realize the universe may have already noticed you, measured you, and scheduled something around you? If the countdown ends and nothing happens, we'll forget. We always do. But if something does happen, we may never get a warning again, because the signal already served its purpose. It wasn't meant to scare us. It wasn't meant to be decoded. It was meant to exist, quietly, patiently, until the moment it. And if you're wondering why you've never heard this discussed openly, there's a reason for that. Uncertainty is manageable. Panic is not. History has shown that humanity handles slow disasters better than sudden realizations. Climate change took decades to accept. Pandemics were denied until they couldn't be. Now imagine announcing that a signal from deep space may be tied to a future event we don't fully understand. Not an invasion, not an attack, just something scheduled, something inevitable. You don't prepare people for that. You let time soften the edges. There's also another layer to this story, one that rarely leaves closed rooms. When scientists mapped the coordinate again using updated data, they noticed something odd. The location wasn't static. It wasn't moving randomly either. It was drifting, slowly, predictably, as if it were following a path, not fast enough to be a spacecraft by our standards, but far too precise to be natural, almost like a massive object coasting through space, conserving energy, waiting for the right moment to engage. And then came the simulations. Thousands of them. Most showed nothing, but a few showed scenarios where the object never arrives, because it doesn't need to. In those models, the event happens here, on Earth, triggered not by arrival, but by interaction, by resonance, by alignment of frequencies, like striking the right note on a cosmic instrument and watching something invisible suddenly respond. This might sound like science fiction, and maybe it is, but every major discovery once did. Radio waves were fantasy. Black holes were impossible. Time dilation was absurd, until it wasn't, until reality caught up with imagination and quietly passed it. Another disturbing detail emerged from the data: the signal's strength. It was incredibly powerful. Too powerful, strong enough that if it were meant for communication, it could have been detected across half the galaxy. That's inefficient, wasteful, unless the goal wasn't to communicate, but to guarantee detection, to make sure that whatever was listening couldn't miss it, including us. Some researchers believe the signal functions like a cosmic timestamp, a marker embedded into the fabric of space. Something advanced civilizations might use the way we use dates, to say this is when it begins. This is when something changes, not for one planet, but for an entire region of space. And then there's the human factor, because signals don't exist in isolation. We responded, not directly, not intentionally, but we responded by changing. Since 1977, our technological growth has exploded. Computers, artificial intelligence, global networks. We went from analog whispers to digital screams in less than a century. If the signal was a test, then our reaction wasn't silence. It was acceleration. What if the countdown wasn't waiting for them to arrive? What if it was waiting for us to reach a certain point? A level where observation becomes possible without interference, where a species can be studied without being destroyed by the knowledge. Or worse, where a species becomes capable of understanding what it's being observed by. Here's the unsettling part. There are reports, unofficial and unconfirmed, of similar signals being quietly removed from public databases. Short bursts, weak patterns, dismissed as interference. But when placed together, they form a loose network, like checkpoints, not messages, but confirmations, as if the universe is periodically checking in, making sure conditions remain stable, making sure nothing unexpected has changed. We like to think we're explorers, that we're looking outward, but what if this entire time we've been inside someone else's experiment, a controlled environment, a small, noisy pocket of intelligence allowed to evolve freely, until it either stabilizes or destabilizes itself? If that's true, then the silence of the universe isn't comforting. It's procedural. Observational silence. The kind that exists not because no one is there, but because talking would interfere with the results. And so we wait. Not consciously, not officially, but we wait. Every telescope pointed a little longer at empty space. Every anomaly reviewed twice instead of once. Every unexplained glitch quietly archived instead of dismissed. Because somewhere deep down, the scientific community understands one thing very clearly. Once you hear a signal like that, you never truly stop listening. Maybe nothing will happen. Maybe the countdown will end, and the universe will continue exactly as it always has. Cold, vast, indifferent. But if something does change, it won't be dramatic. No ships in the sky, no alarms, just subtle shifts. Physics behaving slightly differently, signals that used to fade suddenly persisting, patterns emerging where randomness once ruled. And by the time we notice, it may already be too late to ask questions, because the signal was never an invitation. It was a timestamp.